Hello students, today we will discuss arrays and sorting techniques on arrays. In ICSE we don't have sorting techniques for any multi-dimensional arrays but only single dimensional arrays. So sorting technique or sorting, first let us see the definition of sorting. It is nothing but rearranging elements of an array in either ascending or descending order. This is the primary definition for sorting. Now, techniques, if we talk about techniques, there are many techniques, probably more than 20 different styles of or 20 different techniques for rearranging these elements of the array. But in our syllabus, we are only going to cover one, that is selection or sequential sort. Selection or sequential sort and bubble sort. So let us see one. The first one we'll pick is selection sort or sequential sort. What is sorting? It is rearranging of elements of an array in either ascending or descending order. We will look at, practically we will also look at how these things happen. At any moment, if you feel that you need to note down, please pause the video and then note down whatever is written on the board. We will first talk about selection or sequential sort. Selection or sequential sort. So let us take an array. The layout of the array that I am going to take, unlike in the book that is given in a horizontal layout, I am more comfortable and you may be comfortable in a very different way. Whatever layout it is, but ultimate objective is to rearrange it. So I have taken the vertical layout of the array, and this array is going to have 1, 2, 3, 4, 5 elements. So let's say we have 5 elements in an array. The declaration for this array in Java is done by the statement int arr, the name of the array, followed by the dimension, single dimension, equal to new. So new is a keyword or an operator which is used to do dynamic memory allocation. New int is a data type, and how many elements you would like to allocate in the memory. So we can say that this is the visual representation of this statement. So this is int arr, so name of the array here is arr, and how many elements will be there? There are 5 elements. So the elements are identified in an array by their subscript, like 0, starting from 0, 1, 2, 3, 4. So if you count, it's actually 5 elements. But when we use the subscript, it always starts from 0. There is a different video where I have explained that why does the array index start from 0. So now let us see how the selection sorting technique will rearrange the values that we put in this array. So let us go slowly. We have, let's say we have the values as 4, 2, 1, 5 and 3. So these are, or let us make it as 14, 12, 11, 15, 13. This is better. So they have no resemblance with the subscript values. Students can very easily confuse that there is 0 here also, or there is 1 here also, there is 1 here also. So we have taken a different set of values so that you are not confused. So let us start. In this in sorting or selection sorting, uh, first is we must know number of something called number of passes required. This is very important. Number of passes required. Number of passes required is, this is a question. Answer is total number of elements. Total number of elements minus 1 or n minus 1 number of passes. So we need to perform something called pass. We'll explain what is pass, but first you note that number of passes required to perform the rearrangement or selection sort of this array which has got 5 elements is total number of elements minus 1 or n minus 1 number of passes. This is one. Second is this is one. Second is, what is a pass? What is a pass? Pass is comparison of elements of the array. Pass is comparison of elements of the array according to the technique. According to the technique. So every technique has its own unique way of rearranging or sorting. But ultimately what we need to know is in what is a pass and how many number of passes are required. So if we know what we are doing in a pass and how many times we are doing it, then we have achieved our selection sort. So let us try and sort this out. As I have told earlier, any moment you feel that you did not understand, kindly pause or you can go back and watch it again. So first, according to selection sort, the comparison starts with the 0th or the first element. 0 means the 0 subscript or the first element. We compare this first element with the second element. And the comparison is whether the first element is greater than this second element. Why are we comparing whether 14 is greater than 12? Because we want to rearrange the array according to ascending order. So we are comparing first 14 with 12, whether 14 is greater than 12. If 14 is greater than 12, then we will use a separate variable which will also have to be of integer type. Let's say we name that as t. T stands for temporary. Then we'll copy 14 over here to the temporary variable. Override this 14 with the value of the second element. So after that 14 will be copied back over here. So we'll overwrite the value of 14 on top of 12. So this is how we interchange, because when we compare, then every time we'll find that there is a number which is bigger than the other, we'll have to interchange. So first we found 14 is greater than 12. So what happened? 14 went down, 12 came up. Next comparison, we are still in a particular pass. So next comparison will be whether 12 is greater than 11. Yes, 12 is greater than 11. So 12 will be copied here first. 12 will be copied here. And 11 will overwrite the 12. So 11 will overwrite 12 and 12 will come and overwrite 11. So we have achieved another comparison, but we have not completed the pass, because one pass means all the comparisons that are required for a particular array. As many elements are there. So next comparison will be 11 with 15. Is 11 more than 15? No. 11 is not more than 15. So we will not do the interchange. Whenever the condition fails, the interchange will not take place. The interchange takes place only when a particular number is bigger, because we are trying to arrange it according to ascending order. So we will not be interchanging. The last comparison that we will make is 11 with 13. Is 11 greater than 13? No. So we will not interchange. So as a result of all the comparisons, what we have achieved is we have completed one pass. Or we can say that this is pass number 1. So if you remember from the previous writing, I had mentioned that the number of passes required will be the total number of elements minus 1. So we have already completed the first pass, but we haven't finished all the pass, so we still have to continue this because we haven't rearranged it according to ascending order yet. Only the result of the first pass or pass number 1 is that whichever is this or whichever was the smallest number in this array has gone to the top. So if we make another picture, this is what is the result of the first pass. 11, 14, 12, 15, 13. So this is the result. So this looks clean. Here this looks very dirty. After the first pass, the same array has to undergo another set of comparisons, this time for second pass. The second pass begins with the second element. Like the first pass began, first pass began with first element. Second pass begins with second element. So we compare now 14 with 12. We don't go back. We always go forward, because we don't need to compare whether 14 is greater than 11. The previous number of comparisons for the first pass has already achieved that the smallest number in or the smallest element in this array has already gone to the top. So the second set of comparisons the second pass starts with second element. 14 is greater than 12, yes. So we will use that temporary variable t, and 14 will go here, so that 12 can overwrite the 14. So 12 has overwritten, then 14 will overwrite 12. Watch carefully that no more comparisons will succeed here, because 12 is the second smallest element in the array. So 12 if we compare with 15 is not bigger. 12 if we compare with 13 is also not bigger. So just one successful comparison took place in the second pass. But it's not that we will not conduct all the other remaining comparisons. For a particular pass, we have to complete the all said number of comparisons. So now as a result of this second pass or second pass or pass number 2, this is the result. 3, 4, 5. So you have 0, 1, 2, 3, 4. So these are the subscript. 11 and 12 now, after 2 passes we already have 2 elements in order, but the others are not in order. We have 14, 15 and 13. So when we start the third pass, when we start the third pass, the third pass starts with the third element. So is 14 greater than 15? Yes. No. 14 is not bigger than 15. So what will happen? We'll compare whether 14 is bigger than 13. Yes, it is. So we will use t, the temporary variable, and copy 14 here. 13 will go and overwrite 13, will go and overwrite 14, and 14 from the temporary variable will come and overwrite 13. So we have completed the third pass. See how we proceed, or how are we proceeding. Now we have the result of the third pass, which is 11, 12, 13, 15 and 14. So the last pass is the fourth pass. This was pass number 3. Now we are going to start rearranging our pass number 4. So here we start, and in fact this is the only comparison that we have, 15 with 14. Is 15 bigger than 14? Yes. Then we'll first copy 15 here. Remember that these are the steps as we speak. That is exactly how it has to be performed when we write the program. So 15 is bigger than 14, so 15 goes to T. Then 14 will come and overwrite 15, and then 15 will come and overwrite 14. So this is the end. Now we have achieved the last pass, which is pass number 4. And as a result of pass number 4, you will see that the array elements according to selection sort are all in order. So if you have seen 11, 12, 13, 14, 15, this is exactly what is selection or sequential sort. Selection or sequential sort. Now how do we how do we write the program for the sorting technique? Let us take a look at the program. Before writing the program, I am once again writing drawing the array here. And remember what I said, total number of passes needs to be kept in mind. And what did we write here? 14, 12, 11, 15, 13. Say these are the elements. The first thing that you have to remember is number of pass, and second is number of comparisons per pass. So these two are nested inside each other. So when we write the loop, we write for let's take a variable, let's say outer, for running the number of pass, or we can take say p for running the number of pass, p. So p, I am taking for granted that p and all the other variables which will be used are already defined. So p equal to 0, p less than 4. Why 4? Because 0, 1, 2, 3 means how many? 4. 4 means if the total number of elements is 5, then the number of comparisons will be 4. So starting from 0, if I say, then 0, 1, 2, 3 means 4 number of comparisons, or 4 number of passes, sorry. P plus plus, next, what did I say? Nest inside this the number of comparisons. So for the first one, you must have noticed that for the first one, the number of comparisons is more. But for the second element, the number of comparisons decreases. For the third comparison, the number of comparisons will further decrease. So that is why we have to set a relationship between the outer loop and the inner loop. So this is the comparison loop. So I am taking C is equal to P plus 1. Why did I write P plus 1 here? Pay attention. I wrote here P plus 1 because first time when P is 0, I am going to pick this number to be compared. Why did I say C equal to P plus 1? So C becomes 1 means I am going to compare 14 with 12. So C must be always one step ahead at the beginning of P. Then C should be less than 5, C plus plus. Now let's compare. The name of the array was ARR. So we compare if ARR of P is greater than ARR of C. So what do? I told you we'll take a temporary variable. So when 14 is bigger than 12, what did I do? I took T and I assigned 14 over here. So I'm writing T and I'm saying ARR of P. Watch this again and again. Those students who do not, who are not able to catch it in one glimpse. So T is equal to 14 I wrote here, but how I wrote it here? I did not write a T is equal to 14. I wrote T is equal to ARR of P because every time the value of P will change and subsequently ARR of P, whatever it will represent, that also will change. So T is equal to ARR of P means first time P is 0, so 14 will come to T. Next, 12 needs to overwrite 14. So 12 has to go and overwrite 14. So what do? We say ARR of P is equal to ARR of C. This is how overwriting will take place. But you must have noticed that before I overwrote ARR of P, I took away the value of ARR of P and gave it to whom? T. Then the last comparison, the last, exchange is between C and T. So that brings us to the end of the sorting technique for selection sort. So what has happened here if I revise? P starts with 0 means I start with the first pass. So every time this P's loop will run means P0, then P1, then P2, then P3. So 0, 1, 2, 3. So 4 number of passes. But you look at this C's loop, it is dependent on P. So when P is 0, see how many times C's loop will run. C will start with 1. So 1, 2, 3, 4. So that means 4 number of comparisons. So when P is 0, number of comparisons is 4. 4 number of comparisons. When P becomes 1, then C starts from 2. So that means the number of comparisons will be 2, 3, 4. So only 3 comparisons. So when P is 0, number of comparisons 4. When P is 1, number of comparisons is 3. When P is 2, that means third pass, number of comparisons will only be 2. And for the last time when P is 3, the number of comparisons which the inner loop is running will be only 1. So I hope you understood, and this video we end here with this code. I am taking for granted that you already know that how to input values into an array, how to declare these variables P, C, ARR and T, and how to print the elements of the array ARR using another loop. Thank you.